Now let's see another interesting SSCU question, particularly from WAEC. They say, what volume of oxygen at STP will react with carbon to form 4.40 grams of carbon 4 oxide according to the following equation? Carbon solid plus oxygen gas giving you carbon 4 oxide gas. And they gave us the RAM of oxygen as 16 and carbon as 12. They also told us that 1 mole of a gas at STP is actually 22.4 dmq at STP. So now, without much wasting of time, let's first of all make a very important statement here, because the equation here is to give us a guideline. We observe that we are looking for volume of oxygen. What volume of oxygen at STP will react to carbon 4 oxide to give us 4.40 grams of carbon 4 oxide. Now, if you observe this question, 1 mole of carbon was used, 1 mole of oxygen was used, and it gave us 1 mole of carbon 4 oxide. That makes our questions very simple. Now, with this information, remember what I told you, always start what is given to you. It gives you a guide to pick up your formula. Now we have small m. Small m is 4.40 grams. That is, for carbon 4 oxide is 4.40 grams. That is for carbon 4 oxide. And then we have the molar volume of gas, which is 22.4 dmq. And interestingly, we also need to get the big M. The big M, we need to find it this time around because it's not given to us. What they gave us is the relative atomic mass. And we can find it because carbon 4 oxide is actually 1 carbon plus 2 oxygen. And carbon we know here is 12, and 2 times 16. And that will give us 12 plus 32, and that is 44 grams per mole. That is the molar mass of carbon 4 oxide. So we now have our big M. We have MVG, molar volume of gas. We have the mass given to us for carbon 4 oxide. And we are looking for the volume of oxygen. Somebody said, but talking about oxygen and carbon 4 oxide, why we are going to use this simple formula is because everything here is carbon 4 oxide is 1 mole, and oxygen gas is also 1 mole. So they are on the same level, So there will be no problem at all in this calculation. Now, to find the volume in dmq, we already have what is listed. Don't forget what I told you about the small m is equals to volume given to you over the standard 22.4 dmq times the Mr. Big M. And with this information, I already know what my small m is. 4.40 grams is equal to, I don't know what this V, I'm looking for it, but I know this one is 22.4 dmq, and I know my big M from what I calculated is 44 grams per mole. So what do I do next? Without wasting time, I just cross multiply this, and I have V dmq times 44 grams per mole is equal to 4.40 grams times 22.4 dmq. Okay, so bring out my V dmq. What do I do now? I divide everything by 44 grams per mole. This side also 44 grams per mole. And that will bring out my V dmq. 4.40 times 22.4 divided by 44. And the answer is 2.24 dmq. That is the volume of oxygen that will react with carbon 4 oxide to form 4.40 grams of carbon 4 oxide based on this wonderful chemistry equation. Now look at another interesting SSC question. Actually, it is even in solubility. And solubility has this formula. But I want to tell you that this formula that I gave to you is it's called magic formula, that can even treat chemistry questions of diverse, pattern and styles. Now, in this case, like I said, there's a formula for solubility, but I will still use the magic formula which I've been doing all this while to solve this simple chemistry question. Now, what do? Just list out what you have. You have C for potassium hydrogen carbonate, which is what? 0.40 mole per dmq. What else do you have? Sorry, this is CMQ, sorry. And then you also have the big M, very interesting, 100 gram per mole for, in the case of potassium hydrogen carbonate. And then, what are we looking for here? Small m. We also have V, 100 CMQ. And remember what I told you, always convert to DMQ. So that will give us 100 divided by 1,000. That will give us 0.1 DMQ. Now, with this information, remember the formula? I have two magic formulas I've been sharing with you. I said the first one is N is equal to CV. Second one is N is equal to M over big M. With these two formulas, you can really solve so many chemistry questions. Now, what do? In this case now, I have C, I have V, I don't have N. But M over big M represents N. So that means that M over big M is also equal to CV. Okay? Now, I have my small m is what the one I'm looking for. Just put it there over big M. Sorry, let me fix the big M at one, which is 100 gram per mole. Is equal to, what's my C? 0.40 mole per dmq. What's my V? Interestingly, it's now 0.1 dmq, or preferably 10 dmq. Okay, but I'm looking for who? M. All right, so without wasting of time, if I cross multiply this way, M times 1 is M, so my M is simply 0.40 mole per dmq times 0.10 dmq times 100 gram per mole. And with my calculator, like I said, it's your best friend in chemistry calculations. You just punch it, 0.4 times 0.1 times 100, and your answer is 4. Very simple. 4. So my answer is 4 grams. Remember I told you that this is a solubility question. It has a formula for it. But with this magic formula of N is equal to CV, and N is equal to M over big M, I tell you, you will solve so many chemistry calculations without stress. If 11 grams of a gas occupies 5.6 dmq at STP, calculate its vapor density. The molar volume of a gas is 2.4 dmq at STP. So what do? Like I said, I'll give you the magic formula. Now, first of all, let's start what we have. We have small m is 11 grams. We have volume in dmq is 5.6 dmq. Okay, let me list it out this way for clarity's sake, so that it will not be mixed up. It's 5.6 dmq. Then we also have the molar volume of a gas and 22.4 dmq. And interestingly, what we are looking for here is vapor density. Let's say I've forgotten, vapor density in chemistry is actually 1/2 the molar mass of the gas. Is 1/2 of it. So just have that at the back of your mind. So let's move. Now, like I said, the magic formula. I have M, I have VDM, I have MVG. So how do I come out of this? I have 11 grams of the gas, okay? I have VDMQ based on the question. I have my molar volume to 2.4 dmq. So let's see what I can use here. Now, remember that small m, only m is equal to small m over what? Big M. Okay? But unfortunately, I don't have the big M. But I know that the big M, that the VD is equal to 1 over 2 whatever the big M is. But I have this. I also have this. So which formula will help me? I know that M is also equal to VDMQ all over 22.4 DMQ times the big M. I know that very well. Okay, but I have this. I have this. I have this, so I can find this. Simple? So let's do it. So now I have here is 11 gram is equal to 5.6 DMQ over 22.4 DMQ times the big M. So what do? I simply cross multiply this way. So I now have 5.6 DMQ times the big M is equal to 11 gram times 22.4 DMQ. So what do? To get this, divide both sides by 5.6 DMQ and this side also by 5.6 DMQ. Chemistry is quite interesting, and then the big M is waiting for you. And then you get your best friend, the calculator, and punch it. You have 1 times 22.4 divided by 5.6. And without much stress, the answer of big M is 44 grams. But the question is, calculate its vapor density. So based on the formula, vapor density is equal to 1 over 2 times 44 grams, since it's the molar mass of the gas is 44 grams. And you know that will definitely give us 2 divided by 44, 22. The vapor density is absolutely 22. Now let's look at this interesting SSC question. Sodium nitrite will decompose and nitrate 5 to give us nitrate 3 and another oxygen gas. From the equation above, what is the volume of oxygen produced at STP when 8.5 grams of sodium nitrite is heated until no further gas is evolved? Now they gave us the relative molecular mass of sodium nitrite, which is 85 grams, and the molar volume of gases at STP as 22.4 DMQ. Now, interestingly, before we dabble into this and begin to solve, caution is needed. Now, if you look at this question, you observe that what was decomposed was 2 moles, and it gave us 1 mole of the gas. So that calls for serious caution. Now, what are we going to do? They gave us sodium nitrate as 85 grams, but what was used for 1 mole? That means I make a statement here. I will say 2 mole of sodium nitrite actually yielded 1 mole of oxygen gas. So notice the 2 mole. That will affect us in our calculation. That will affect our calculation somehow. So let's see what to do. But before that, let's move on. So we have the big M actually is 85 grams. And then we have the small m, 8.5 grams. And then we also have the molar volume of gas, 22.4 DMQ at STP. And we are looking for the volume in DMQ of oxygen gas. Now, so with this information, we can use our magic formula and get the answer as quickly as possible. So since I have small m, I have big M, I have the standard volume, I have the volume that we're looking for. So I remembered vividly that small m is equal to the volume given or required, all over standard, which is 22.4 dmq, times the big M. And that makes it very fast. So my small m is 8.5 gram. The volume I'm looking for is VDMQ, all over 22.4 dmq. But surprisingly, my big M is going to be multiplied by 2. And say, sir, what are you doing? Yes, by 2. Why do I say by 2? Because we have 2 moles giving us 1. So that will give us, it will now give us 170 gram. Wow. So what I will have here is now 170 gram, not just 85 grams. So be careful when you're solving anything that has to do with this kind of equation. 2 moles, 1 mole. So I multiply it by 2. Okay. So we now have just cross multiply as we used to do. So that will give us volume in dmq times 170 gram per mole is equal to 8.5 gram times 22.4 dmq. So to bring out the V in dmq, divide everything here by 170, sorry. So what we have left here is volume in dmq is equal to 8.5 gram times 22.4 dmq divided by 170 gram. And the answer is absolutely 1.10 dmq. 1.10 dmq. That is the volume of oxygen that will be produced at STP if I use 8.5 gram of sodium nitrate.